Hello everyone, I am Himanshu Vasnani from Department of Mechanical Engineering. I am here to present to you a lecture on the subject non-destructive evaluation and testing. Uh, Subject code is ME419, Unit 1, Lecture 6 today, and the topic is liquid penetration testing and its procedure. Now, the learning objectives for today are to give students a basic understanding of liquid penetrant testing and its procedure, to know its advantages and disadvantages. And today's outcome will be students will have understanding of liquid penetrant testing and its procedure, penetrants, developers. These two terms you will see in the coming slides. Students will understand various factors influencing them and its advantages and disadvantages. So liquid penetrant testing, you can see it is on the right hand side. There is a diagram. In the diagram, there are some red dots. These are nothing. These are some cracks or discontinuities or defects that have been highlighted with the help of liquid penetrant testing. So it is one of the most oldest and simplest non-destructive testing methods. This method is used to reveal surface discontinuities by bleed out or colored or fluorescent dye from the flaw. You can see in the diagram on the right hand side there was a bleed out or a liquid to be drawn into a clean surface discontinuity by capillary action. After a period of time called dwell time, excess surface penetrant is removed and a developer is applied. This acts as a blotter that draws the penetrant from a discontinuity to reveal its presence. What happens is that you take a liquid, you spread the liquid on the surface. On the surface, what happens that the liquid it slowly draws inside the you can say crack or discontinuity with the help of capillary action. You give a certain time for the liquid to settle down inside the crack and then you clean the surface. After you clean the surface, you put a developer. What developer does? The developer, when it comes in contact with the penetrant, it bloats. It bloats so that it can be easily seen, and hence the discontinuity or the flaw is found. You can see in the diagram on the right hand side, it is showing that a crack is there and a red kind of you can say a capillary reaction is shown to you. This red is a penetrant filled in a dye. Okay, sorry, a penetrant filled in a crack. Penetrant filled in a crack, not in a dye. Penetrant filled in a crack with the help of a capillary reaction. So the advantage that a liquid penetrant inspection offers over an unaided visual inspection is that it makes defects easier to see for the inspector where that it does in two ways. Now how it is helpful? It produces a flaw indication that is much larger and easier for the dye to detect than the flaw itself. Okay, it produces a flaw indication. This liquid penetrant testing it produces a flaw indication that is much larger and easier for the eye to detect than the flaw itself. Okay, because the detect is so small that if you use go for LPT, then it is become visible. Many flaws are so small or narrow that they are undetectable by the unaided eye. Okay, a person with a normal vision can resolve features up to 0.08 millimeters. So, very small flaws, these are also easily detected. Okay. Now, it improves detectability by flaw due to the high level of contrast between the indication and the background, which helps them to make the indication more easily seen, such as a red indication on a white background, or for a visible penetrant, or a penetrant that glows under ultraviolet light for a fluorescent penetrant. What they do that they have a level of contrast, okay, between the indication and the background. If you are using a red indication, you can go for a white background. What happens because it makes the visibility. You can see in the diagram it is using a red penetrant, okay, for proper visibility. And if you are going for a fluorescent penetrant, then you need ultraviolet light and a dark room for which it will glow, and you can easily find out the crack. And okay, then let's go further. Liquid penetrant testing. Liquid penetrant testing, you can say, it is one of the most widely used NDT technique. Why? Because it is easy to use and it's flexible. Flexible means it can be used to inspect any material provided that surface is not extremely rough or porous. Okay, excuse me. Okay, right. So it can be used to inspect almost any material, the provided that the surface is not extremely rough or porous. Materials that are commonly inspected using this method include metals, glass, ceramics, rubber, and plastics. Now, metal, glass, you easily see that surface is smooth, but ceramics also, you need to have a surface that should be smooth. Okay, and rubber, plastics. However, liquid penetrant testing can only be used to inspect for flaws in surface that are commonly found defects earlier in the continuity series, and these can be easily inspected or found, okay, with the help of this liquid penetrant testing. Now, various steps of liquid penetrant testing. The exact procedure for liquid penetrant testing can vary from case to case, depending upon several factors such as the penetrant system being used, the size and the material of the component being inspected, the type of discontinuities being inspected in the component, and the condition and the environment under which the inspection is performed. Okay, so you can say that the exact procedure, what they do, that various factors are you should consider that what penetrant system you are using and the size and the material of the component. Secondly, the type of discontinuities, because suppose if that material is used earlier also, then you have a slight idea that this kind of discontinuities are already found. So you can or you have a slight idea that this kind of discontinuities can be expected in the component. And last but not the least, the condition and the environment under which the inspection is performed. So now we are going to summarize the general steps. Like the first is surface preparation. So it is one of the most critical steps of liquid penetrant testing is the surface preparation. The surface must be free of grease, oil, water, or other contaminants that may prevent penetrant from entering flaws. I repeat once again, one of the most critical steps of liquid that the surface must be free from any kind of oil or grease or water, because what they do, they avoid penetrant to enter inside the defect or flaw. And if the penetrant is not allowed to enter inside the defect or flaw, then the LPT test cannot be performed in a better way. So the sample may also require etching if mechanical operations such as machining, sanding, or grid blasting have been performed. These and other mechanical operations can smear metal over the flaw opening and prevent the penetrant from entering. Means what to do? These operations, these might also smear metal over the flaw. So what happens? The penetrant will not able to enter inside completely. So we should clean the surface, and this process is called the surface preparation because any kinds of contaminants or any kinds of you can say uh, movement of disruption of liquid penetrant test. So now the penetrant application. Once the surface has been thoroughly cleaned and dried, The penetrant material is applied by spraying, brushing, or immersing the part in a penetrant bath. Means that when you have cleaned the surface, then the penetrant material, it is applied by three ways, either by immersing the material in the bath. That is possible if you have a small work, if you have a small either by spraying or brushing. Now, spraying will take less time as compared to brushing. So nowadays, spraying technique is commonly used in penetrant application. Okay, you can see in the diagram on the right hand side, it is showing that how this red color is a penetrant, how it is easily flowing inside the crack with the help of capillary action. Okay, the crack is in the solid. You can see it is written solid there. The penetrant dwell. The penetrant is left on the surface for a sufficient time to allow as much penetrant as possible to be drawn or to seep into a defect. What does mean? The penetrant is left on the surface which was cleaned. The penetrant is left on the surface for a sufficient time to allow as much penetrant as possible. Okay, the penetrant is allowed to go inside the crack or the defect. Okay, this is called as penetrant dwell time, the time which is given to the penetrant. Penetrant dwell time is the total time that a penetrant is in contact with the part surface. Okay, when it is in surface, then only it will flow. So dwell times are usually recommended by penetrant producers or required by the specification being followed. Now dwell times, these uh, vary from material to material. Okay. Now either the producers of the penetrant, they have recommended, okay, you can use this material for at least this time for proper flow of penetrant to the cracks, or based upon the past experiences or experimentations, you can easily do your work according to that also. The times vary depending on the application, penetrant material used, the material and the form of the material being inspected, and the type of discontinuity being inspected for. Okay, these are the conditions that what should be the dwell time. It depends upon the application, the penetrant material used, because the producers of the penetrants, they might have tell on the, you can say, on the surface only key of the box that this is the required dwell time. Then the material, the form of material being inspected, that is the workpiece, and a type of discontinuity being inspected for. Minimum dwell time range from 5 to 60 minutes. They is the minimum dwell time. Now, generally, there is no harm in using a longer penetrant dwell time. If you go a bit hard, longer, there is no harm. As long as the penetrant is not allowed to dry, you should not allow it to dry. This is the condition. The ideal dwell time is often determined by experimentation and may vary specific to a particular application. Yeah, it says, because it is saying that it range from 5 to 60 minutes. So this has a range. So the ideal dwell time is determined by experimentation and may vary specific to a particular application. This is the most delicate procedure because the excess penetrant must be removed from the surface of the sample, while the removing as little penetrant as possible from the defect. You can see in the diagram on the right hand side, it is they are removing the penetrant from the surface. Why they are removing? Because the penetrant has already got filled inside the cracks after a certain dwell time, penetrant dwell time. It has filled inside the cracks. So now they are removing the excess material from the excess penetrant from the surface of the sample. But one thing should be taken care of, that the removal of penetrant from the defects should be as little as possible. Okay, because the purpose for applying penetrant was filling of the this cracks with penetrant. The purpose was that filling of cracks with penetrant. So we have to remove as little as possible from the defects. So depending upon the penetrant systems used, this step may involve cleaning with a solvent, direct rinsing with water, or first treating the part with an emulsifier and then rinsing with water. Okay, depending upon the penetrant system used. Okay, this step may involve cleaning with a solvent. You have to choose a system. How will you remove it? Okay, either you can remove it with water only, or first you are removing with a solvent and then with water, or you are first treating with an emulsifier and then rinsing with water. It depends upon you what kind of process you want to apply. Okay, obviously it depend upon the material and the penetrant also. So now we developer application. The next step after cleaning, a thin layer of developer is then applied to the sample to draw penetrant trapped in flaws back to the surface where it will be visible. Okay, a thin layer of developer is then applied to the sample to draw penetrant trapped in flaws back to the surface where it will be visible. Okay, what they do, that they spread the developer on the surface. Okay, and what happens, that the penetrant inside the cracks, inside the defects or the flaws, they what they do, when they come in contact with the developer, then the visibility is possible. Okay, now how it do, developer, they come in a variety of forms, either in the form of dry powders or dust, or maybe in the form of wet developers. So when it comes to wet developers, then you apply by either dipping inside the developer or just by spraying. Okay. Uh, if the but workpiece is small, then dipping is possible. If workpiece is larger in size, then spraying is the option. And if you are using dry powder, then dusting, you can simple apply powder on the surface. The indication development, the developer is allowed to stand on the part surface for a period of time sufficient to permit the extraction of the trapped penetrant out of any surface flows. The developer is allowed to stand on the part surface for a period of sufficient time. Uh, there was a dealt time with the penetrant also, that they gave given them a sufficient time. The here the developer was also given a sufficient time, okay, so that it can show the extraction of the trapped penetrant out of the surface flaws. Okay, the developer here is also given a sufficient time to show the extraction of the trapped penetrant out of any surface flaws. So they say that the development time is usually minimum of 10 minutes. It may take to some longer time if some tight cracks are there, but they say that minimum, the normal time is minimum of 10 minutes. Now the next is inspection. Inspection is then performed under appropriate lighting to detect indications from any flaws which may be present. Now, lightning means if they go for some particular, there are some inspection rooms in which their flaws can be easily highlighted and then can be inspected. Clean surface, the final step in the process is to thoroughly clean the first the part surface to remove the developer from the parts that were found to be accepted. Okay. Now, after the all the process, we found the after the inspection, you thoroughly clean the surface to remove the developer from the parts that are found to be. Advantages for this liquid penetrant testing is high sensitivity, like small discontinuities can be detected, few material limitations, that it has very less material limitations, metallic and non-metallic, magnetic and non-magnetic, conductive and non-conductive materials may be accepted or inspected. Then rapid inspection for large areas and volumes. If they go for spraying, with the help of spraying, they easily understand. Then suitable for parts with complex shape, that is also possible. Indications are produced directly on the surface of the part and representation, constitute a visual representation of the flaw. Then portable materials are available in aerosol spray cans, and then low cost. These are the common advantages. Then we go for the disadvantages, that only surface breaking defects can be detected. Only materials with a relatively non-porous surface can be inspected. Pre-cleaning is critical since contaminants can mask defects. This is one of the most important things. Then metal smearing from machining, grinding, and grit or vapor blasting must be removed. The inspector must have direct access to the surface being inspected. Okay. The surface finish and roughness can affect inspection sensitivity. Then multiple process operations can be performed and controlled. Uh, like multiple process operation must be performed and controlled. Okay, one should be cleaning of acceptable parts or material is required. Chemical handling and proper disposal is required. So these are the simple disadvantages, but they do not affect much as compared to the advantages. The advantages are much better. Now, penetrants, this term that I have used in the process many times. So we are studying about the penetrants. Now, penetrants are what? These are carefully formulated to produce the level of sensitivity desired by the inspector. Okay. The penetrant must possess a number of important characteristics, like it should easily spread over the surface of the material being inspected to provide complete and even coverage. Means the surface should have penetrant very smoothly spread. Okay, to provide complete and even coverage. Then it should be drawn into surface breaking defects by capillary action. Okay, the cracks on the surface, they are the penetrant easily drawn into it by capillary action. And, it will remain in the defect but remove easily from the surface of the part. It will remain in the defect but it gets removed easily. I tell you once again how. When you are cleaning the material from the surface, so the issue is that the penetrant should be in the defect and only in the flaw only for further processing. So this important class should be there, that while cleaning it should remain in the defect, but it should be removed easily from the surface of the part. Okay, then remain fluid so it can be drawn back to the surface of the part through the drying and developing steps. Right, it should be highly visible or fluorescent brightly to produce easy to see indications. While after detection of the flaw, then they should be visible. No, okay, so it is not to be harmful to the material being tested or the inspector. That is very self understood. Then perform same formulations to address a variety of inspection applications. I've seen you in the earlier diagram, the red color on the solid filling inside the red, that is penetrant. Okay. Some applications call for a detection of smallest defects possible within another application. The detectable defect size may be larger. Okay, so it depends upon the application. The penetrant that are used to detect the smallest defects will also produce the largest amount of irrelevant indications. Okay, if you are going for smaller defects, then also it will show you some amount of irrelevant indications which should be avoided. Okay, then the standard specification classify painted material according to their physical characteristics and their performance. Uh, yeah, then penetrant material they come into two basic types. The first is fluorescent penetrant, and they contain a dye. Fluorescent penetrants, remember, they contain a dye or several dyes that fluorescence when exposed to ultraviolet radiation. They require ultraviolet radiation for detection. Okay. Whereas visible penetrants, they contain a red dye that provides high contrast while the white developer background. The developer is having white background. White developer is used. So it will have a plain background, and then the penetrant is having a red dye. So automatically it will become visible very easily. Whereas if you go for a fluorescent penetrant, then you have to go in a dark room with ultraviolet radiation, which exposes the fluorescence of the penetrant. Then fluorescent pen system are more sensitive than visible penetrant because the eye is drawn to the glow of the fluorescing indication. That is okay. However, visible penetrants do not require a darkened area and an ultraviolet light in order to make an inspection. Visible penetrants do not require a darkened area. Fluorescent penetrants they require a darkened area. Okay. So visible penetrants they do not require darkened area and ultraviolet light to make in order to make an inspection. So in this way, visible penetrants has its good things. Fluorescent penetrants they also have their good things. Both are used. Both materials are used depending upon the application. Now penetrants are then classified by the method used to remove the excess penetrant from the part. You can understand what importance does penetrance has. Based upon the application, they are classified based upon the method used to remove the excess penetrant from the part. Then also there are four methods. Then first is method A, water washable. Penetrant can be removed from the part by rinsing with water alone. This penetrant contains an emulsifying agent detergent that makes it possible to wash the penetrant from the part surface with water alone. Can you understand? The penetrant can be removed with water alone. They also have inbuilt an emulsifying agent that makes it possible to wash the penetrant from the surface part, from the part surface, sorry, with water alone. So these are called as self-emulsifying system. Now method B is post-emulsifiable lipophilic. The penetrant is soil soluble and interacts with oil-based emulsifier to make removal possible. Okay, then third method C is solvent removal. They require the use of a solvent to remove the penetrant from the part. And the method D is post emulsifiable hydrophilic. They use an emulsifier that is a water soluble detergent which lifts the excess penetrant from the surface of the part with a water wash. Can you imagine there are four methods and these are all means important to understand. Okay, method A, B, C, D. Water washable, post emulsifiable lipophilic, solvent removal, and post emulsifiable hydrophilic. Each has their own importance. Each is important. Now, penetrants are then classified based on the strength or reactivity. How it is able to strength or reactivity of the indication that is produced by for a number of very small and fatigue cracks. So the level is into five steps. Level half, level 1, 2, 3, 4. The half is ultra low sensitivity. One is low sensitivity. Second is medium sensitivity. Third is sorry, half second. Then next is high sensitivity. Then you have ultra high sensitivity. So how these levels are understood? Half, one, two, three, four. The producers for the classifying penetrants into one of the five sensitive levels are use a specimen with small surface fatigue crack. The brightness of the indication produced is measured using a photometer. Photometer. Now the developers. We studied about developers earlier also. Now we will study in detail. The role of the developer is to pull the trapped penetrant material out of defects and spread it on the surface of the part. Okay, so that it can be seen by the inspector. What the developer may be dry, in powder form or wet form. It is spread on the workpiece, and its role is to pull the trapped penetrant material out of defects and spread it on the surface of the part so that it can be seen by the inspector. Now, developer used with visible penetrance creates a white background so that there is a great degree of contrast between the indication and the surrounding background. Okay, with the white background, you can easily find out the degree of contrast, that it has a greater degree of contrast between the indication and the surrounding background. Understood? Between the indications and the surrounding background. We have to understand this. On the other hand, developers used with fluorescent penetrants both reflect and refract the incident ultraviolet light, allowing of it more interest or more, allowing it to interact with the penetrant, causing more effective fluorescence. Okay, because they what they do, the fluorescent penetrants they reflect and refract the incident ultraviolet light. Okay, so it is easier. Then, according to the standards, the developers are classified based on the method that the developer is applied, that is a dry or is suspendable, D is fluorescent, dollar based, E is visible salt based, visible dye, salt based. Then F is special application. So I think will discuss all these things. And dry powder developers are generally considered to be the least sensitive, but they are inexpensive to use and easy to apply. They are easily available, so they are less expensive, and also you know that it is also easy to use. So dry powders have application, but they are least sensitive. They are least sensitive. Dry developers are white, fluffy powders that are can be applied to the thoroughly dry surface in a number of ways, either by dipping part in a container of developer or by using a buffer to dust parts with the developer and placing parts in a cabinet where the developer is blown away. Okay, so here the dry developers they also have a you can say method of application. Okay, like by dipping parts in the container of developer or by using a buffer to dust parts with the developer. Okay, so how this is working, you can understand. Since the powder only sticks to areas of indications, since they are wet, powder developers are seldom used for visible inspection. What happens that the penetrant inside the crack, it is still in liquid form. So whenever you try to apply that powder, what happens that powder sticks only to areas of indication since there are wet uh, developers. What happens that the powder on the penetrant, okay, they stick because the penetrant is wet. Okay, so what happens that it is easily visible. The flaw becomes easily visible to the inspector. So for this purpose only, powder developers are normally used for visual inspection. Then comes the water soluble. As the name implies, water soluble developers. These consist of a group of chemicals that are dissolved in water and form a developer layer. When water is evaporated away. Okay. The best method. The best method for applying water-soluble developers is by spraying it on the plant. Understood? Spraying it on the plant, the best method. The part can be wet or dry. It depends. Okay. Dipping, pouring, or brushing the solution onto the surface is sometimes used, but these methods are less desirable. Somehow, you may try to dip or pour or brushing the solution on the surface, but this is less desirable. You can simply apply with the help of spray. Okay. Now, drying is achieved by placing the wet but well drained part in a circulating warm air dryer with a temperature of this 21 degrees centigrade. Proper developed parts will have an even white, light white coating over the entire surface. Okay, so in this way, water soluble developers they are used. Then what are suspendable developers? Water suspendable developers consist of insoluble developer particles suspended in water. Very interesting to understand that water suspendable developers they consist of insoluble developers particles suspended in water. Now, water suspendable developers require frequent stirring or agitation to keep the particles from settling down of suspension. Okay. Now, water suspendable developers are applied to parts in the same manner as water soluble developers. The previous said about water soluble developers. Then the parts are dried using warm air. Now, non-aqueous developers. Non-aqueous developers they suspend the developer in a volatile solvent and are typically applied with a spray gun. And non-aqueous developers are commonly distributed in aerosol or spray guns for portability. The solvent tend to pull the penetrant from the indications by solvent action. Okay, they pull the penetrant by solvent action. Since the solvent is highly volatile, post drying is not required in this. And special applications, you can say that plastic or lacquer developers or special developers and are primarily used when the permanent record of the inspection is required. Let's go further with this. Uh, Preparation of the part. One of the most critical step in the penetrant inspection process is the preparation of the part. Okay. All coatings such as paint, varnishes, plating, heavy oxides must be removed to ensure that defects are open to the surface of the part. Okay, such coatings like paint, they should be removed. This requires time. This requires time. If the parts have to be machined, sanded, or blasted prior to the penetrant inspection, it is possible that a thin layer of metal may have smeared across the surface and closed it off, closed off the fence. Obviously, that if you are using a workpiece or a part that has been machined or used for some other applications, then also a thin layer of metal it can disturb. Okay, so you have to prepare accordingly. Also, some cleaning operations such as steam cleaning can cause metal smearing in softer materials, right? So this layer of metal smearing must be removed before inspection, obviously. So you can see in the diagram here how this penetrant application and dwell time happens. The penetrant material can be applied in a number of ways, like spraying, brushing, or immersing the part in a permanent bath. Okay, in a penetrant bath, sorry. Once the part is immersed in the penetrant bath, the part is cleaned well so that penetrant doesn't uh, have time to enter inside the defect that is present. So two dwell modes options. If immersion dwell, the keeping the part immersed in the penetrant during the dwell period, the part is in the penetrant only. And drain dwell, letting the part remain drained during the dwell period. This gives better sensitivity. Okay. Now penetrant dwell time. This I have told you earlier also that what is the importance of penetrant dwell time. And the major purpose is that allows the penetrant the time necessary to see or to be drawn into a defect. Okay, and the time required to fill the flaw depends on the number of variables. Variables like surface tension of the penetrant or contact angle of the penetrant or dynamic shear viscosity of the penetrant or the atomic pressure at the flaw opening or the capillary presence at the flaw opening or the pressure of the gas trapped in the flaw by the penetrant. These all variables we have to consider while going for any penetrant dwell time. Okay. Then the radius of the flaw, the distance between the flaw walls, the density or specific gravity of the penetrant, microstructure property of the penetrant. The ideal time is often determined by experimentation and is often very specific to a particular application. For example, the table shows the dwell time requirements for steel parts according to some of the commonly used specification. You can see this table. Now this table, as you can see, it is showing like source, then form, the discontinuity, dwell time for water washable in minutes, then dwell time for post immersion. So if you go with the casting form, you can see these kind of discontinuities they happen like in casting, extrusion, forging welds. So you can see that in the casting, porosity and cold shed they are found. Normally it takes 5 to 10 minutes as a dwell time and 10 minutes for dwell time for post immersion. So in casting, they know either porosity or cold shed these kind of problem arise. So they have a data that around this to this for cold shuts they require 5 to 15 time of dwell time, while porosity they require 5 to 10 minutes of dwell time. Okay, so here they have a particular idea based upon the past experiences. For extrusions or forging welds, you can say that they have the fine lapse and lack of fusion or porosity. These they say that these kind of discontinuities are found, and normally say they that for the lapse they don't know the exact say, dwell time, but for dwell time for post retrieval they have a value. Then lack of fusion also, then they have 30 minutes of dwell time for post retrieval and 20 minutes of dwell time for post retrieval. And for all other processes, we have like in cracks are developed or particles are involved. Then they have a particular value. Okay. Then if you go with the ASME boiler and pressure vessel codes, then in the casting you will easily see that the porosity discontinuity have a dwell time of 30 minutes. There is no for post emulsive labor. For post shot is 30 minutes, for lapse is 30 minutes, for extrusion is 30 minutes, and then okay. So we have to see these are not data that is fixed. These are data that have been found based on past experience. Okay, like if we go with the casting, this one, then you can say that 5 minutes dwell time is required in both the cases, and 5 times dwell time this is required for post analysis. Okay, so here you can easily understand that what importance does dwell time holds. Okay, and what kind of processes that have been done inside the whole testing procedure. Okay, so penetrant removal process that I have told you earlier also that how the penetrant removal is done from the surface discontinuity. In the coming lectures, I'll show you more about how this penetrant removal process is done now with the MCQs. They say that the technique is based on the ability of a liquid to be drawn into a clean surface distinguished by capillary action. What do we call? This technique is called as liquid penetrant testing. I have told you in the starting only this testing. What is this about? Interesting about this test. In the second, you have in liquid penetrant testing, the surface must be free of oil, grease, water, or other contaminants that may prevent penetrant from entering flaws. What do you think? It should be true or false? I think it should be true. Okay, because the surface, so because for dwell time, I have told you many times during penetrant producers or required by the specification being followed. And the fourth MCQ is about fluorescent penetrant system are more sensitive than visible penetrant system. Yes, because eye is drawn to the glow of fluorescent indication, we require a dark room for giving ultraviolet radiation, ultraviolet light. Sorry, for an ultraviolet light, it will give you a fluorescent indication. Then the role of a dash is to pull the trapped penetrant material out of defects and spread it out on the surface of the part so that it can be seen by the equipment. This is called as a developer. A developer is used to pull the trapped penetrant material out of the defects. Okay, so it can be easily seen by the inspector. So a developer is the answer. Dry powder developers are generally considered to be least sensitive, but they are special to use and easy to use. Right, right. Okay, let's go further. The the best method for applying water soluble developers is by spraying it on the part. The part can be wet on water. See, either immersing is possible or spraying is possible. Spraying the seed is much better because the part is inside, big or small. Spraying will help better. It is easier to do. Okay, so here the best way is applying through spraying method. Okay, that's true. Then eighth question in liquid penetrant testing, minimum dwell time typically ranges from I tell you 5 to 16 minutes. Okay, so we have to be attentive during the lecture so that you remember all the things. Then ninth question, these penetrants contain a dye or several dyes that fluoresce when exposed to ultraviolet radiations. These are called as fluorescent penetrants. These are called as fluorescent penetrants. Now these penetrants they contain red dye that provides high contrast against the white developer background. These are called as visible penetrants. Okay. So the MCQs were quite simple. The MCQs were quite understandable by you. Okay. Why I am giving you these MCQs in order to make you understand that whatever we are studying that has some importance. And through this MCQ, you are able to revise whatever you have studied in this, you can say, today's lecture. Okay, we have studied about what is all about LPT, liquid pattern testing. We have studied about developers. We studied about penetrants. We studied about the whole procedure. So today's topic was quite interesting. Today's topic was really good in terms of you can say knowledge point of view. And this technique, if you study more, if from the references, so you will find it that it is much more interesting and it it has an impact on the industry because of its applications. So liquid penetrant testing is you can say it is a practical application and the inspector is also you can say comfortable with the results because the results are effective in nature. Okay, and these are the references which you have to, which you want, you can see. See, references are given for you to just go through these and have a better idea of the topics that we have covered so far. It will give you uh, you can say while studying you will know that you already know this, but uh, you can say addition to your knowledge will be beneficial for you. So I request you all to study these all references, which will be helpful to you, and if possible, then I'll provide you with more references. So I thank you all for having me today in the lecture. Thank you all.